Hello, fellow EHS classmates. In this presentation, I will be discussing America's use of water and the impending crisis we're headed for if we don't find ways to conserve and reduce the amount of water that we use on a daily basis. So what I'm going to do is lay out some of the facts for you in regards to just how much water we use daily in our homes and how much for agriculture and how much for industry, and how it is that if we live on the blue planet, a planet covered in 70% water, that 36 of our 50 states are currently or will be very soon facing severe water shortages. This animation gives you an idea of just how tiny a fraction of the Earth's water is fresh water, only 3%. And of this 3% fresh water, you have to subtract the 70% that is locked away in the polar ice caps, and a lot more that's too deep underground to be used or is too saline. So now we're down to less than 1% of all of Earth's water being readily available fresh water. Then, if we take into account the pollution inflicted upon this tiny fraction of available fresh water, we reduce the amount of usable water even further. About 46% of the lakes in America are too polluted for fishing, aquatic life, or swimming. Each year, 1.2 trillion gallons of untreated sewage, stormwater, and industrial waste is dumped into U.S. waterways. What this means is that a lot of our surface water is too polluted to use without treating it at a wastewater treatment plant. Treatment is much more expensive than just pumping groundwater that has been purified by natural processes out from underneath the Earth's surface. And so as our lakes and rivers become more heavily polluted, we're beginning to rely more and more on aquifers and natural springs. We still use much more surface water than groundwater. We actually use about 80% surface water and 20% groundwater, but that's on the rise, and actually now about 50% of the U.S. population relies on groundwater for their drinking water. This is a quick refresher for middle school earth science class of the hydrologic cycle. The sun's heat warms the surface of lakes and rivers, causing evaporation. This evaporation turns into clouds and is precipitated back onto the earth. And it's actually this filtering process through sand and silt that purifies the groundwater before it returns into aquifers. The amount of water we pump out of the ground in America alone is staggering. According to the 2005 U.S. Geological Survey, we use 82,600 million gallons of groundwater per day. To be fair, the underground chambers that hold all this groundwater, called aquifers, are enormous. The Ogallala Aquifer, located in the Midwest, spans across 8 states, or 174,000 miles. But we're removing the water from the ground 15 times faster than the water cycle can replace it. It takes time for rainwater to filter down into these underground chambers, and the constant demands for irrigation, industry, and residential use are not conducive to patience. Basically, what we're using is nowhere near what's being replaced. The aquifer I just mentioned, the Ogallala, may be used up within the next 50 years. Now, this aquifer supplies irrigation for roughly 1/5 of the wheat, corn, cattle, and cotton grown in the United States. So what will we do when we can no longer water these crops? Aside from depleting supplies, groundwater pumping causes a host of other issues. We've all seen the news stories on the sinkholes swallowing up trees and houses, and that poor guy that was sleeping in his bed at night. Most of these occurrences are caused by overpumping groundwater. As the water table lowers, it creates a downward seepage pressure that can suck surface soil into empty pockets. With groundwater pumping, you also have the problem of aquifer salination in coastal areas. Imagine a scenario in which a major metropolitan area sits near the coast, and a smaller town is situated right on the coast. That major metropolitan area pulls hundreds of thousands of gallons of fresh water daily out of an aquifer that's shared by that small town. Now, Eventually, the suction created by the large city begins to pull seawater into the groundwater used by the small town, contaminating their drinking water. This scenario is becoming a more common occurrence as groundwater pumping increases. And it's not just aquifers that are feeling the effects of all the water we use. As I mentioned earlier, groundwater pumping accounts only for about 20% of annual water use. The other 80% comes from surface water use. It's lakes, reservoirs, rivers. That's an estimated 328,000 million gallons a day, and 82% of that surface water used is freshwater. Now, what happens when you lower the underground water table by groundwater pumping and you remove water from lakes and reservoirs at an even faster rate? Let's take a look at Lake Mead as an example. This reservoir supplies water to nearby Las Vegas and to desert golf courses and agricultural ventures and lawn watering. Lake Mead is one of the largest reservoirs in the world, but it's still being depleted at an alarming rate. The reservoir is currently holding only 40% of its capacity. Water shortage in the Southwest has led the Southern Nevada Water Authority to propose a $15 billion pipeline project to pipe in water from rural areas in eastern Nevada, which of course has the residents of these rural areas extremely worried about the consequences to their local ecosystems and to their job security. Most people in this area ranch, and they need the water to sustain their cattle. But as Pat Mulroy, General Manager of the Southern Nevada Water Authority, explains, 90% of Nevada's water goes to agriculture, and that generates 6,000 jobs, which is less than the Mirage Hotel generates. So for Pat Mulroy and many others, the question is one of economics, job creation, and urban expansion over ecological preservation. So what do you think? Now that I'm on the subject of urban expansion, let's discuss what other factors play into the water crisis. Bigger cities equal more pavement. We're losing 750 billion cubic meters of permeable surface, that's dirt-covered surface, every year. And while most of the earth is obviously still covered in permeable land, this does start to add up. When rain hits a non-permeable surface, it's unable to return into the ground to refill aquifers. Instead, it runs down roads and into storm drains. More paved area also means less trees, and the importance of trees in water conservation cannot be overstated. Trees pull water up from the ground, and through evapotranspiration, basically breathing, they release water into the air. One tree can breathe out 250 to 400 or more gallons of water per day. And inland rainfall is largely due to this ability of trees to evapotranspire. Climate change also has an enormous role to play in water shortage. As temperatures rise and ice caps melt, seawater is beginning to infiltrate low-lying areas and contaminate drinking water. These effects are already being felt in the Caribbean. And when we think of climate change, we usually think of flooding and rising sea levels, but droughts are also occurring as climate changes, and these droughts have a major impact on the land's ability to recharge its groundwater supplies. So I've skimmed over some of the things we Americans do with all the water we pump out of reservoirs and aquifers, but I'd like to get a little more specific. This chart from the U.S. Geological Survey website shows us that domestic use accounts for a small fraction of our water withdrawals. 31% of water used goes to irrigation. This includes water used for growing crops, frost protection, chemical applications, weed control, and the maintenance of parks and golf courses. Thermoelectric power plants use about half of all water withdrawals to create steam, which spins turbines to create electricity. More water, cold water, is used then to cool the steam back into water. In our daily lives, we use water for showering, doing laundry, drinking. The average American uses around 100 gallons of water per day. We rarely stop to think about just how much we use. If you own a high-efficiency toilet, each flush will use around 1.6 gallons of water. Conventional toilets use around 6 gallons of water. Most toilets in America are not high efficiency. That costs us around 6 billion gallons a day. And you might be surprised by the hidden water costs behind items like t-shirts and light bulbs. We are aware that hot tubs use a lot of water, about 500 gallons on average, but it takes 700 gallons of water to produce a t-shirt. A pool uses around 18,000 gallons of water. It also takes 18,000 gallons of water to produce 4 pounds of steak, and 38 gallons to create 1 glass of wine, and 200 gallons for $1 of dog food. If you want to see more of what these screenshots are showing you, just Google National Geographic embedded water. Perhaps we don't consider these things because Americans are the kings of water misuse. We're pretty much spoiled. We can turn on our taps and out flows cold, safe, fresh water for much less than we pay for basic cable. We use 3 times the volume of Lake Mead yearly just on watering our lawns. 50 to 75% of water used in arid or semi-arid regions like Arizona goes on lawn watering. We create grass where there should be none. And what we're doing is removing water from one area of the country and we're putting it elsewhere, which is changing the whole system and wrecking the flow of water in current watersheds. We're turning deserts into grasslands and grasslands into deserts. Housing developments are being built with no regard to whether or not there's enough water for the people that will move into them. It's generally thought that our water will never run out, and if it does, that you can just pipe it in from elsewhere, some other place with plenty of water to go around. For example, if Los Angeles had to live on just the water it had locally available, it would only be able to sustain about 3 million people. Los Angeles' current population is 18 million people. So developments expand unrestricted in places like Vegas that already can't sustain their population. Even Atlanta, Georgia, located in a state filled with 70,000 miles of streams and 400,000 acres of lakes, began to run out of water in the early 2000s. Lake Lanier, the primary source of water for 5 million people in the Atlanta metro area, a 38,000-acre lake, dropped 15 feet in October of 2007, prompting the state to issue severe water use restrictions. And Atlanta's population is expected to grow by 50% by 2015. Atlanta's unrestricted water use has Florida and Alabama very angry. Both states sued the state of Georgia for using more than its share of water resources, but since Georgia is the upstream state, it basically gets first dibs on however much water it needs to use. Now, what's kind of funny and sort of sad, Georgia's mayor during this drought decided to place the blame on the Army Corps of Engineers for releasing water from Lanier to ensure the survival of 3 endangered species, 2 mollusks, and the Gulf sturgeon. I'm going to show you a related news clip blaming California's drought conditions on an endangered species.
Tomorrow night, we will be doing this program live from California in the valley that hope forgot. Now, folks, there is incredible suffering in this region because of government that has put the interest of a 2-inch Delta smelt minnow before the people of California, farmers that have farmed for generations. And Ainsley Earhardt is now live in California with a preview of where we will be tomorrow night for a very important, very big show that impacts the whole country. Ainsley.
Sad story. You're one of the only ones covering this too, Sean. This is the San Joaquin Valley. We're about 3 hours north of L.A. It's called the breadbasket of America because most of the fruits and vegetables and nuts that you're buying in the grocery store are grown here in this area. But the controversy here is 30 to 40,000 farmers and workers out here have lost their jobs, and it's all because of that 2-inch minnow that you were mentioning, Sean. It's a really devastating story, and let me tell you how it affects you. What happened? The environmentalists were out here and they discovered the Delta smelt, that 2-inch minnow, was getting stuck in the water pumps, a crucial part of the irrigation system here. That irrigation system takes water to about 2/3 of the farmland here in California. Well, they took it to court, and by law, because the Delta smelt is an endangered species, the Delta smelt had to be protected. So the pumps were completely shut off. Farmers were left without any water to their land. The farmers out here are saying that the government is choosing fish over families.
Now, with everything I just explained throughout this presentation on how Americans use our water with no regard for giving nature time to replenish its supplies and no concept of environmental limitations, is it really fair to point the finger at an endangered species? And regardless of its fairness, this type of finger pointing distracts us from the real reason farmers don't have enough water for crops. We don't conserve what we have. We think that supplies are limitless, and they're not. Fresh water is precious and finite, and we should be doing everything we can to preserve and protect it. Without fresh water, there's no future for us. Our bodies are nearly 60% water, and yet we treat water with no respect at all. Americans need to seriously consider the repercussions of our actions. The average American uses 100 to 200 gallons of water per day. The average African uses 5. We're lucky enough to have access to clean water virtually everywhere we go, while 1.1 billion people worldwide can't access safe water at all, and 2.4 billion people worldwide lack adequate sanitation. At any given time, half of the world's hospital beds are occupied by patients suffering from waterborne illness. I think it's time we start pointing the finger at ourselves, and we start realizing what we really have.